In the previous video, we looked closely at how to test the difference between a cycloalkane and an alkene using bromine solution, because the alkene will quickly decolorize bromine solution, whereas the cycloalkane will not. And we decided that the reason for that is the double bond in the alkene is used up in what is called an addition reaction with the bromine solution. So in mentioning that that was an addition reaction, what we now need to consider is that there's actually 3 different types of addition reaction at National 5 level. And they all involve a compound that adds across a carbon-to-carbon double bond. And because they require that carbon-to-carbon double bond, they all involve alkenes. So when we think of addition reactions, we're thinking of adding something across a double bond. So if we look at the first type, it should be very familiar to us because it's the one that we've already looked at. It's the bromine type addition reaction, and it involves any of the halogens. So bromine could be an option, or we could also look at fluorine or chlorine or iodine or the other halogens. So what we have is an alkene, because we have to have the double bond present, and we add any of our halogens, so any of our diatomic halogen molecules, and what we form always is some kind of dihaloalkane. All that means is 2 halogen atoms adding across an alkene to form a saturated compound, dihaloalkane, and you'll notice it changes from ene to ane as well. So to illustrate that by example, we could have our double bond in this compound here, which contains 2 carbons, which makes it ethene, and we can add bromine across this double bond. So what actually happens then? Well, the way to draw it out as a full structural formula is to basically draw what we start with in terms of atoms. So I'm going to keep everything that I already had. I've got 2 carbons and 4 hydrogens. And all that happens is when it comes into proximity of this bromine molecule, the double bond will open up like a sort of gate. Okay, it goes from being a closed double bond to opening up. And that means our carbon atoms can now bond to something extra each. Because remember, carbon has to be surrounded by 4 bonds. So in this case, 1, 2, 3, 4. 1, 2, 3, 4. Now that that central double bond is just a single bond, we can add each of our bromines onto each of our carbons. And now if we try to name this, all we have to do is indicate which carbons the bromines are on, and then determine how many carbons we have. So we're going to in fact have 1, 2, dibromo, because there's 2 bromine atoms, eth, because there's 2 carbons, and it's an alkane, or a haloalkane now, because there are no more double bonds. So whatever the halogen is, we always form a dihaloalkane when we react one with an alkene, and that is halogenation, or halogenation, because we're adding a halogen. The second type we're going to focus on is very similar. In fact, it's the exact same mechanism, which just means how the reaction proceeds. But instead of adding a halogen, we're now going to look at what happens if we add a hydrogen, which is slightly different. So I could have an alkene, again, because I require that double bond in an addition reaction, and I can add a hydrogen. So I will use the same starting material. I will just stick with ethene to keep it simple. And remember, hydrogen is also a diatomic molecule, so there's going to be 2 hydrogens. Now, what happens when we add hydrogen across a double bond? Well, again, we keep all the atoms that we had before, 2 carbons or 4 hydrogens. We open up the double bond and we add in the chemical that is being added. And you'll notice that instead of now having an alkene, very simply, I've actually formed an alkane. Because that is the difference between an alkene and an alkane. We simply have CnH2n, CnH2n plus 2. Here's my plus 2 hydrogens. And adding 2 hydrogens to an alkene, I can form an alkane. And that can be quite a useful reaction if you start with an alkene but you actually in fact wanted an alkane. So, in forming this new alkane, I can call it simply ethane, because all I've done is add 2 hydrogens to ethene, which breaks the unsaturation, forming a saturated alkane compound. So in a hydrogenation reaction, we form an alkane from an alkene. Which brings us to the third type and the last type, which is very similar sounding, but is quite different, and that's a hydration reaction. So that's not to be confused with hydrogenation, because hydration, in fact, involves water instead of hydrogen, and that makes things a little bit different. Now, why is that? Well, because water is not a simple diatomic molecule. There's not 2 atoms, one which neatly goes onto each carbon. This time, we have to consider that water looks like that. We have 1 oxygen and we have 2 hydrogens. We actually have 3 atoms that all have to go somewhere here. So, what we want to do is the same thing again. We always start at the same. We know that the double bond is going to be added across. So, we turn it into a single bond. Add in what we already had. And I should note as well, I could flip this round. I could draw the hydrogens that I had at the bottom as well. It doesn't matter, as long as each thing that I'm adding goes on to each carbon of the double bond. That is very important. But for just now, let's just stick with drawing them at the top to keep it simple. I'm going to retain all those hydrogens, and this time what's in fact going to happen is I'm going to break one of these bonds in my water molecule. At this stage, it doesn't really matter which one, as long as you know that one carbon is going to have a hydrogen added to it from this part of the water molecule, and the other carbon is actually going to get both an oxygen and a hydrogen added from the other part of the water molecule. This group here is actually a very important group. This collection of 2 atoms, this functional group. It's actually called a hydroxyl group, and we'll look at that more in the next topic in Unit 2. But for just now, what we need to know is that when we add water to an alkene, what we've actually formed is an alcohol molecule. And we can tell it's an alcohol because it has this O and H joined onto it. So we went from ethene to ethanol, which is one of the simplest alcohols that we can form. And as I say, this will be the focus of the next topic. But for just now, what we need to know is that these are the 3 different types of addition reactions involved at National 5. They all involve alkenes. They all involve adding a compound across the alkene's double bond, and they are halogenation, where we add a halogen, hydrogenation, where we add a hydrogen molecule, or hydration, where we add water. And we need to know what we form in each of these reactions. A dihaloalkane, an alkane, or an alcohol.